Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes, okay? Today we're gonna talk about rational function and I'm gonna give a quick overview. I'm gonna talk about different sections of rational function. Then I'm gonna end this series with how do you graph rational function, okay? Please, like I always say, if you've not subscribed, liked, or shared the video, I don't know what you're waiting for. And don't forget to click the notification bell so when I post new videos, you'll be the first person to know. And also try as much as possible to review previous videos so that because as we keep on going down this series, the new videos will be built upon knowledge from the previous ones. All right. So what is a rational function? A rational function is a function that is a ratio of polynomials. So basically, we are talking about any function of one variable x. It's called a rational function. I have different forms of formulas for it. Because I know some of you are writing, I'm going to write it down and also write each of the functions as well. And I'm going to talk about some of the notes to keep in mind. So let's go. So the first thing here is that you know that a rational function. So when we talk about a rational function, so a rational function is a function that is a ratio of polynomial. So a rational function is a ratio of polynomials. So basically, we mean that it's any function, all right, of one variable x. Okay, so a ratio of one variable x is called a rational function. So how can this be expressed? So it's expressed as, now it has a general formula, okay? And I'm gonna write each of the general formula. How is it expressed? So you can have f of x, so that means any particular function can be p of x divided by q of x, so that means a particular function plus d, or in some cases, you can have a rational function as f of x is equal to a over bx plus c plus d. So it does not really matter. So it's a ratio of polynomials. So you need to know that such that for this to be a rational function, the denominator qx, okay, or bx plus c can never be what? Equal to 0. Okay, so for this to be a rational function, qx can never be equal to 0, or bx plus c can never be equal to what? 0. So now in this case here, in this example, where's the rational function? So that means in this example here, the rational function here is the p p of x divided by q of x, or you can say the a b of x. These are the rational functions. So therefore, I can now say p of x over q of x, or a over what? Bx plus c represents what? The rational function. Okay? So that means this one here, the p of x over q of x here, represent the rational function, and a over b of x represent also the rational function. Another thing as well you need to know is that for this to be rational functions as well, the a, the d, and the the b, okay, as well as c. So all these numbers here, so a, b, c, and d are all constant. So a, b, c, and what? D are constants. Okay? So this is how a rational function look like. So that means the ratio of two polynomials is a rational function. It can also be ratio of constant, because a constant technically could be said to be a polynomial. Here, in this case, x is equals to 0, is raised to the power of 0, sorry, and divided by a linear function here. So for example, an example of a rational function. So let's pick an example here. So let's say we have y is equal to x squared plus x minus 2 divided by 2x squared minus 2x minus 3. Now, this is a rational function because if you look at it carefully, this looks exactly like in the previous slide. This looks exactly like the first one, px over qx. Now, but in this case here, the d is 0. So that means this is the same thing as saying the px over what? Qx. So that means we have a ratio of a quadratic equation on that quadratic equation, but in this case, the d is what? 0, okay? Now also, you can also have another kind of polynomial, rational function as 2 divided by, let's say, x plus 7 plus 9. It's still the same thing, but in this case, it's in the form of what? A over bx plus c. So it's form of what? A divided by bx plus c plus d. So that means the d here is 9, the a is 2, the b here is 1, and the c is 7. So this is also a polynomial because you can also write this as a x raised to the power 0, are you seeing it? Divided by b x raised to the power 0 plus c, okay? So you can see that you can also say this is also a ratio of polynomials as well, okay? Because in this case, sorry, not 0 here, 1. This is 1 because it's x raised to the power 1. So in this case now, you can see that this is also a ratio of polynomials. So when you say we have a rational function, it's a ratio of polynomials that is a rational function. So when you have two polynomials having ratios, okay, please, if you've not watched my videos on polynomials, please go back and watch it, all right? So you can just go to the playlist, search polynomials, and you can see the different types of polynomials. We have quadratic equation, we have linear, we have cubic. Does that make sense? So any form of polynomials, the ratio of both of them is called a rational function. All right, so there are some things I want us to take note of, all right? Some things you need to take note of for a rational function. Now, the first thing that you need to note is that the numerator of a rational function can be a constant. So that means, as you see, like in this case, the numerator is a constant, like here, all right? So the numerator of a rational function can be a constant. So the numerator of a rational function okay, can be a constant. Okay, so for example, you can have maybe y is equal to 1 over 4x plus 2. You can have y is equal to 2 over 3x squared plus 5x plus 7. Okay, you can have something like this. So it does not really matter because you can have a constant as the numerator. Now, but also what you need to know is that in a rational function, the denominator of a rational function can never be a constant, all right? So the denominator can never. Cannot, all right? So the key word is that the denominator cannot, all right? Or let's put it this way. Let's say the denominator of a rational function, the denominator of a rational function, all right, cannot. All right, the key word is that it cannot be a constant. Okay, so the denominator cannot be a constant. So for example, you can't have something like 4x plus 2 divided by 7. This is wrong. All right, or you cannot have something like 3x squared plus 5x plus 7 divided by 2. This is not a rational function. Okay, so for it to be a rational function, for you to have a constant, only the numerator is allowed to have a constant. All right, Now, the next one as well is that is either the numerator or the denominator could not be a polynomial. So it's possible that the numerator or denominator could not be a polynomial, but the fraction does not represent a rational function. So if the numerator and the denominator is not a polynomial, then that fraction is not a what? Rational function. So what we are saying is that for it to be a rational function, if you look back, if you go back to what I said, is that a rational function is the ratio of polynomials. So that means one polynomial must divide the second polynomial for it to be a rational function. All right? So one polynomial must divide the second one. So, but if either of them is not a polynomial, that can be a rational function. Okay? So if either of them is not a polynomial, that can be a rational function. So number 3. So if either the numerator or denominator, so if either the numerator or denominator is not a polynomial, all right? So remember we talked about polynomials. These are degrees of x. It could be from all the way from 1 all the way to infinity, okay? Then the fraction so the fraction form does not represent a rational function. So the fraction form does not represent a rational function. So for example, if you have something like, let's say we have 5 plus, let's say root x divided by 2 minus x. This is not a rational function because you can see here the numerator is not a polynomial, although the denominator is a linear function because x is power 1, but this is not a what? The numerator is not a polynomial, so this is not a rational function. Or if you have another one, let's say we have 3 plus 1 over x divided by 7 minus x squared. Now you can see in this case here, this is not this is a quadratic equation. So that means this is a polynomial, but the numerator as well is not a polynomial. So that means this cannot be a rational function. Or maybe if you have something like 3x minus 5 divided by 1 over x plus 2. Now we have a linear function in the numerator, but the denominator here is not a polynomial. So that means this is not a rational function. So for it to be a rational function, you have to have both the numerator and the denominator. They both have to be a what? A polynomial, because a rational function is a ratio of a what? Of a polynomial. All right, so let's see what we're going to talk about here. So what I'm going to talk about in this series, I'm going to talk about 4 things. So I'm going to talk about the asymptotes, okay, and how do you graph it, okay? I want to talk about the asymptotes of a rational function and how do you graph it. And also under the asymptotes, I'm going to talk about how do you find the holes of a rational function, how do you find the vertical asymptotes, how do you find the horizontal asymptotes, and how do you find the slant or oblique asymptotes. Then under the graphing, I'm going to talk about some of the rules on how to graph and how do you sketch. So basically here, what we're going to discuss, all right? Okay, so the first thing we're going to talk about, I'm going to talk about asymptotes. We're going to talk about asymptotes of a rational function. So the first thing we're going to talk about the holes of a rational function. Okay, Then after we talk about the holes, we're going to talk about the vertical asymptotes. Then we're going to talk about horizontal asymptotes, okay? I'm going to talk about how do you find horizontal asymptotes. Then after horizontal asymptotes, I'm going to discuss how do you find the slant or oblique asymptotes. All right, so these are the 4 things I'll talk about: the holes, the vertical asymptotes, the horizontal asymptotes, and the slant asymptotes. Then when we are done with that, and you can find that, then I'm going to show you how do you graph, okay? We're going to talk about graphing of a rational function. So I'm going to talk about the rules and how do you do that, okay? And we're going to do some sketching as well. All right, so this will be how do you sketch rational functions. So when you have a ratio of 2 polynomials and you are told to sketch it, so what do you do? How do you go about it? All right, and that will be that for that. Okay, so that is how, that is a quick overview of rational functions. So basically, when we talk about rational functions, we're talking about the ratio of 2 polynomials, okay? So you can also have a constant associated with it. So like you can see, D can also be 0, all right? So you can add that as well to the 4th one if you want to, that you're gonna have 2 rational functions. So it's 2 polynomials, that the ratio of 2 polynomials is a rational function, and the value there, the D, is a constant, all right? But you can also have a constant divided by another polynomial, because you can see this constant as a polynomial with x raised to the power 0, all right? So, but you need to know for a rational function, you need to know that it's possible to have a constant here, all right? But the denominator can never be equal to 0 in a rational function, and also that both of them must be a ratio, all right? You can have a ratio for both of them to be a rational function. All right, so that is that for that. So we're going to go to the next one, and I'm going to talk about the holes of a rational function and how do you find it. All right, so I'll see you in the next video, and I'll see you soon. So please make sure you like, you subscribe, and share. And if you have any question, please let me know, and we'll talk about it. See you soon.